In this video, we're going to look at bond dipoles, molecular dipoles, partial charges, and overall polarity of molecules. So the first one we're going to look at is hydrogen fluoride, or hydrofluoric acid. And what you have here is an H and an F. It's a very simple molecule with only one bond. It's linear in shape. And you can see that hydrogen has an electronegativity of 2.1. Sometimes you see it as 2.2. And fluorine is 4.0. So what's happening is the fluorine is pulling much more strongly on the electrons and drawing the electrons toward it. Therefore, it ends up, we should represent that showing a bond dipole of an arrow with like a, almost looks like a plus at the back end, an arrow showing where the electrons are flowing. And since this molecule is very simple, your bond dipole and your molecular dipole are the same. The electrons flow towards the fluorine, which gives you a result of there being a partial, you don't have to worry about the numbers, but you get a partial negative charge on the fluorine and a partial positive charge on the hydrogen, making this molecule polar. Another molecule I want to show, another linear molecule we can look at is CO2. This one is linear, and you can see that oxygen is more electronegative than carbon. You get a difference of about 1, making that a pretty polar bond. So if I show the bond dipoles for that, you can see that they're pulling towards the oxygen. But then, what's going to happen is, overall, these are going to cancel each other out, and there's no molecular dipole. And that's why CO2 is a gas at room temperature. It's very nonpolar, and there's not a lot of intermolecular forces, which we'll learn about later in the year, holding it together. So we showed a linear molecule that was polar, a linear molecule that's nonpolar, and now we're going to take a look at a couple other shapes. So now we're going to look at, let's say, this one. Here you have, sorry, I should get rid of these. Here you have a very symmetrical molecule. You have a trigonal planar molecule where all the atoms bonded to the central atom are the same strength. They all have electronegativity of 4.0. So what this essentially does is the bond dipoles show the electrons going towards the fluorines. However, there's no overall dipole because those all are pulling in a way that they cancel out. Picture three people pulling on ropes that are all tied together in the middle with the same strength. It's not going anywhere. So there's no overall dipole, and this is a nonpolar molecule. However, you can have trigonal planar molecules that are polar, like CH2O, where the oxygen is more electronegative than the carbon or the hydrogens, and you can see in the yellow you have the molecular dipole showing the electrons moving up towards the oxygen. So what the result is that this oxygen is partially negative, and this whole back end of the molecule becomes partially positive. Looking at tetrahedral shapes, if you have 4 atoms that are bonded to the central atom the same, it becomes very symmetrical. The bond dipoles all cancel each other out, and you end up with no molecular dipole. However, if I substitute another element in for one of those, what you end up with is an asymmetry of pull. So the fluorine, again, we use that because it's super electronegative, is going to draw the electrons towards it, and you result with a partial negative charge up here, and then you have a partial positive end in the other region of your molecule. If we look at, where is it? Ammonia, no matter what, ammonia, which is a trigonal pyramidal molecule, or if you have a bent molecule, it's always going to be polar because it's asymmetrical by nature. But here you can see that the electrons overall are pulling up towards the nitrogen. And it has that unshared pair that's not shown there as well. In the overall, so the bond dipoles all show the electrons going towards the end. The molecular dipole is kind of what you get when you add them all up and where it goes. So it shows the electrons flowing up towards the nitrogen in this, and you have a partial negative charge there and a partial positive charge below.